Okay, so how do we do this kind of problem? So they want us to use this table to evaluate f of 2. Well, this is y, this is x, right? So if we want to find f of 2 when x equals 2, what's y? Well, it's 3, and it's that easy. The second question asks us, what's x when y equals 4? So we look at our table, there's actually two answers. When x equals 4, y is negative 2. When x equals 4, when y equals 4, x is 3. And that's that. Is this function one-to-one? It is not one-to-one because I have two different x values giving me the same y values. If I had to graph this, I mean, I'm not going to graph them all, but it'd probably fail the horizontal line test. I'm getting two different x values give me the same y value, okay? So one problem with this that I don't want to confuse you, since this is one-to-one, not one-to-one, it doesn't have a direct inverse, and that's what this is asking us. But we can, for the sake of this problem, we can do this. This tells me what's f inverse of 2. Another way to read that is what's value of x has a y of 2. Because inverse functions are cancel each other out, basically. So if I'm looking at my table, I see y equals 2 here. So that tells me x has to be 1. Okay, so when you do that one in the problem set, check that out. Next question. We have to find a formula. Probably it's a line. Let's see. That increases by 3. That increases by 3. That increases by 3. That decreases by 2. Decreases by 2. Decreases by 2. That tells me the slope is down to over 3 if we make it as a unit rate. Now, if I need to do that, and the problem set I'm making you do this is a point slope form. So we know point slope form is y minus y1 equals the slope times x minus x1. So we know y is y. We know the slope is negative 2/3. Okay, the only thing we have to substitute in are these x1 and y1s, where we could use any of these points. I'm going to choose that one. When x is 2, y is 10. And that's that point slope form. If I had used 5 and 8, I would have had an 8 here, a 5 here. If I had used the 6 and 8, I would have had this. I would have had the 6 here, the 8 here, and so on and so forth. Okay, so point slope form, we don't need to do any more than that. If we had to find the t-intercept of this line, we're looking for when does it cross the x-axis? Well, if it crosses the x-axis or the t-axis, y equals 0. So I could say y minus 10 equals negative 2/3 times x minus 2. And we can just solve this equation. Multiply by the reciprocal of that. So negative 3/2 times negative 10. Negatives cancel out. That would be 15 equals x minus 2. Add 2, add 2. So that tells me it crosses the x-axis at 17, y is 0. If I had to find the h-intercept, that means y-intercept. So that means if we're looking for the y-intercept, x is always equal to 0 any place along that line, right? So in this case, t is equal to 0. So if we go back to our function we made, y minus 10 equals negative 2/3 times 0 minus 2, because x is 0. So that's going to be y minus 10 equals, well, that's 0. So negative 2/3 times negative 2 is positive 4/3. So add 10, but I'm going to rename 10 as 30/3. That way we have the common denominators. So it's going to be 34/3 or 0, comma, 34/3. I'm just noticing h and t, I probably should have written this as h of t minus 10 equals negative 2/3 times t minus 2 for this problem, but what we did with y is fine. That's what I'm going to expect you to do on the problem set, is to use y, because it is just a line. Okay, how do we find the domain? I'm going to ignore this. Well, maybe I'll do that one for you, but that's not on this problem set. I can't divide by 0. Okay, so x can't be equal to -2. So that's not in the domain. I look at the numerator. I can't take the square root of a negative number. So where does 3 minus x, actually what I got to ask is, where is 3 minus x greater than or equal to 0? Okay, so if I solve that inequality, I could add x to both sides. So 3 is greater than or equal to x, and then spin the whole boat. So x has to be less than or equal to -3, because in order to make this be a positive number, it has to be 3 or less. So what's the domain? Well, we just said -∞ to 3, close brackets, right? But x can't be -2, so we got to do in our domain is skip over -2. Okay, so that's how you'd find the domain of that radical function. Hopefully you'll be able to do that on the problem set. To do this problem, though it's not on the problem set, the domain of this, well, it's an open circle at -1. Most of you got this right in the exam. Closed-in circle at 5. Alright, and then the range goes from -1, and that's open. It goes all the way up to +3, which is closed. Okay. Last problem.
Brian Emerson.
Okay, so let's do this problem. The domains. Let's figure out the domains of these pieces. I'm going to use this quadratic piece from -∞ to -2. And it's closed at -2, open at -∞, because you can't get there. Then we're going to use this horizontal line piece from -2, and that's open because it's not filled in, to +1, and that's closed because it's filled in. And then we're going to use this absolute value piece from 1 to 4. That's closed. What I want you to think about is, why can't I use a closed in on both? What prevents that? What prevents this from me having to be closed in both those places? I know it's not filled in, one's not filled in, but think about that. So let's come up with these equations. This is the quadratic equation. I see that it's open and upside down, so all quadratic equations will have this form if we put it in vertex form. Okay, because it's opening down, I know the A has to be negative. I'm also seeing that it's just almost it's going down 1, left 1. So if I know, if I think about a plain old x squared, when x is 1, y is 1. When x is -1, y is 1. So if it's just that 1x squared, it's going to have this up 1 over 1, up 1 over, then for the 2 it'll be over 2 up 4 because you're squaring it. So I see that this has a leading coefficient of 1. I mean, I could do some fancy algebra with that, but the quick and easy way is just to know it's going to be -1. Then the vertex of this parabola is that x is -3, y is +2. So x minus a minus becomes +3 squared plus 2. So that's that piece. For this middle piece is just the horizontal line y equals 2. For this absolute value, I see a vertex. We're going to use that same pattern. It's just an absolute value graph function. I see that it has a slope of 2. So this is a stretch, a vertical stretch of 2. So 2, absolute value of x. Now, what's the x for that vertex? Positive 2. What's the y for that vertex? Negative 1. And that's how you come up with a piecewise defined function for that graph. Okay, hope that'll help you do that on the problem set.